record and mute myself.
All right. So Lev asked me to do a presentation on airflow just because I've had some experience with it. And so that's what I'm here to do. I'm going to give you a little flavor of what airflow looks like and how to use it. So what is airflow? Airflow is an open source workflow engine. Everything is programmed in Python. It has a scheduler. It has a monitor. It has tools for monitoring. Also has, if you set it into a parallel deployment environment, it also has built-in tools for managing the handing of tasks to the workers. It's scalable. It will, if you set up your environment to grow as needed on demand, it can scale. It's dynamic. You can create workflows that are responsive to the environment, and it's extensible. You can build on the environment itself. So the basic components of an airflow environment are the airflow database, and in the simplest form, that database is a SQLite database. If you do just a straight install of airflow, it's going to install on a SQLite database. But that database can also be hosted in MySQL, Postgres, or SQL Server. And that database then is used to hold the components and the relationship information of the component. It stores the state of your environment and the tasks in the environment, and it processes all the reads and writes of the actual environment itself, the state of the environment. Then you have your Airflow web server, and that manages the web GUI for monitoring your workloads. It's a Flask web server, and we'll take a look at that a little bit later. And then there's an Airflow scheduler, and the Airflow scheduler is responsible for orchestrating the tasks and retrieving information from the Airflow database about the current state and saying what is the next thing to happen. And then there's the Airflow executor, which is responsible for the actual execution of the code within your Airflow workflows. Installation, if you want to install Airflow in a local environment, it's really very straightforward. You have to have Python installed, and I would recommend at least Python 3.7. But it's very straightforward. You define an Airflow home, which is where in your device do you want to have Airflow install and run from. And once you've defined that, it's pip install Apache Airflow. And your screen will go crazy for a little while, and when it's done, all you need to do is declare an Airflow DB init, and that will initialize the SQLite database. And then you start your Airflow web server on a specific port, and that will open up a web server local instance of the Flask server on that local port. And then lastly, you have to start the Airflow scheduler in order to actually get the Airflow jobs to get the jobs to get loaded and for the actual environment to start doing its work. And lastly, if you want to create an Airflow user, you can run your environment in a non-user environment. And but I would recommend creating a user so that you can work your way around some of the limitations, security limitations. So Airflow runs what are referred to as a DAG. It's a directed acyclical graph. And what this is a DAG is a collection of tasks that are defined in Python code. And it defines the relationship and the dependency between the tasks, and it flows in one direction. You notice that all of these arrows flow downward in this instance. None of them go back upstream. You can do that, but it's not really, you can get yourself into loops and not really a desirable scenario. You always want to think of it flowing in one direction. That's the best practice. So DAGs are made up of tasks, and the basic component of a DAG task are operators. And operators are Python classes that have been defined within the Airflow struct code itself. And you can extend those, you can create new operators, but the basic operators are dummy operator, which is an operator that literally is dummy. It just creates a task plugged into space. You can also run bash commands with the bash operator. And then the big meat of it is the Python operator. And Python operator, and we'll look at some of these, you tell it what is the Python method that you want to call. You can pass arguments to that Python operator, and then it will run the specific instance of that method. And then kind of adjunct to that is a short circuit operator. It's also a Python operator, but a short circuit operator operates on that Python code, and it will accept an exception variable. So you can say, if this happens, stop my day right where it is, don't go any further. And that's really handy in a number of instances. And I just have a couple of examples of API operators. So there are examples for all of the cloud. These are just samplings. This is by no means all of the operators for each of the cloud instances, but here you can run a Azure Data Factory pipeline, or you can delete something from ADLS. You can copy an object from S3, or you can make a Redshift SQL query. You can do a BigQuery query. You can also, do something with Google Cloud Storage. So these are just a inkling of what APIs have been written, and there's lots of contributive APIs even in the actual Airflow official code. So one thing to know is that you can pass information from one task to another. There's built-in functionality called XCOMs, which allows a task to pass information from one task to another. And how this does it is it creates an entry in the database, and that database then is that instance of that variable in the database is there for any task to access. And all tasks have a result XCOM, but you can also set other XCOMs explicitly in your code. Something to note, though, is there is a size limitation to this. Say in the basic SQL DB instance, you have a 48 kilobyte limitation. So don't expect to be passing, this data frame into your XCOM value. There are other ways of dealing with that, and I'll talk about that in a minute. So just think XCOM should be thought of as used for simple passage of results from one task to another, but also remember that if you actually are calling an XCOM from another task, that creates a dependency on that upstream task. So if that upstream task fails, you need to make sure that your dependencies downstream also will take that into effect, rather than having a task downstream that it's looking for a result from an upstream task that it's not technically dependent on, but it is dependent on because it's got an XCOM value. So how do you deal with larger data transfers between tasks, or being less dependent on the results of tasks? Well, you can have your task send information to your information to a database or to an object store, and you particularly want to do that if you're operating on large data sets. Now, the caveat that I'm going to add to this is, ultimately, your Airflow tasks shouldn't be operating on large data sets. Airflow is an orchestration tool. It's not meant to be an ETL tool. So the more appropriate approach is to have the Airflow task trigger a Spark instance to go and do some manipulation, wait for the result set from that task job being completed, and then taking that result and moving on, rather than actually trying to run a Spark job in your Airflow worker. That's not a recommended practice. So I've taken the code that I showed you earlier and how to load up an Airflow instance, and here's my Airflow directory. All of my web server, my database, and my configurations are in here. My logs are in here, and then in this DAGs folder, here are the DAGs that I'm going to be running in my environment. And if we take a look at that, here is my environment. Here's my local environment. I have 4 DAGs, 3 of which are enabled. You can see that the tutorial one down here is paused. There's no need. I didn't have any need to have that one running. And in here, just broadly over, this is the web interface for monitoring your DAGs and the state of things. So you can see here these DAGs. This DAG is run 4 times, this one 7 times, this one 3 times. This shows you the results of various different, how many tasks have succeeded, how many in here you hover over, you can see starting, failed tasks, etc. And then you can trigger tasks here with your pause, your start button. There are in this browse, you can go and review specific DAG runs. So here, we can see what actually happened. Here's the log that take us to this actual DAG run. We can also look at specific jobs, or we can look at tasks. So you've got a lot of visibility to specific activity within the web interface. Just note that you can set variables and configurations. You can set connections to other external sources, etc. I'm not going to go into those too deep because this is kind of a brief overview. So let's take a look at this dummy DAG. And so this dummy DAG is very, very simple. I have a series of tasks, and those tasks, these task 2 and task 3 are dependent on each other, whereas task 1 is not dependent on those. If we look at the code is really basically simple. You can see we've got a dummy operator. Each one of the tasks is a dummy operator. The task ID identifies the actual task that's being run. And this is down here, this start is referring to the definition of that task. You can name these differently. It's not a best practice because you'll be saying, well, it's start here, but over on my graph, it doesn't, where's start? It doesn't say start anywhere. General requirements in your DAG is you need to import DAG from Airflow. So this is Python methodology for importing a module. So we're importing the actual DAG class from Airflow. And then we also need to be importing our operator classes. So in this instance, we're only using dummy. So only class that I've imported is the dummy operator. And so each of these tasks then are calling that dummy operator method, passing it a task ID. And then at the bottom here, this is our relationship, our dependencies. So we've got our start task goes to task 1 end to end, and then the task goes to task 2 and task 3, and then to end. And if we go back and then look at our graph, we can trigger this DAG by going up here and trigger the DAG. And that takes us to the tree view. And in our tree view, these are the instances of the actual runs of the DAG. And you can see the dark green means success. And one would assume that dummy tasks will always be successful. That's one of the reasons to use them, is that they should always be successful. So great. Nice, Chris. We've got this dummy DAG that runs a whole bunch of dummy tasks. Well, let's take a look at a little more complex DAG. And this DAG still has our task 1 and our task 2 and task 3 are dummy tasks. And you can, when you hover over them, you can see that it says dummy task. This one, however, this one is a Python task. This one's using a Python operator. And note that the color scheme here, so you've got a dummy operator and a Python operator. That's why this one's pink. We go look at the code for this. I have a very, very simple method, a function here that says print hello world. That's all it does. And so this hello world task then uses the Python callable with hello world. In this instance, I'm not passing any kind of parameter to my function. So I don't need to define anything for that. There it is. And again, here's our dependency. And if we go and we look at our graph and run this, you can see dark green around that. And then, oh, now they see how the dark green is changing. And then we've successfully gotten to the end. We go look at our hello world and look at our log, we can actually see something here in our log. So this is what I told the task to do, was print out hello world. And so an info is something that is being represented within that Python code. If you tell it to print to screen, you're going to have that show up as an info line. And then we also have info related to the success of the operator. Another thing I want to point out here is in the details view, you can see here's the number of successful instances of the task. This gives us information about where is this DAG actually. So if this path is more complex, you would know where it is, but you also know what the actual file name is that we're actually looking at here. So now I'm going to go to a much more complex DAG, and it's code-wise, it's not more complex, but the DAG representation and dependency is a lot more complex. And if we go and look at and so notice that we now have a bash operator, a dummy operator, and a Python operator. Here's our bash operator here. We've got pink operators that are Python, and then our green are our dummy operators. If we look at the code here, here's our hello world code that we still have. But I've added four different little small functions for actually performing some arithmetic. So we have an add in, so it adds two numbers, subtracts two numbers, multiplies two numbers, and divides two numbers. And then I've created this function to do some math. And what this function does is it takes in some arguments. It's going to define an operator based on the arguments. It's going to have a start and end number for grabbing random intervals, integers. We're going to print those integers out so that we can see them. And then we've got a little if then else set here. So if the operator is add, it's going to add the numbers. If it's a sub, it's going to subtract them. If it's a mul, it's going to multiply. And div, it's going to divide. What I'm going to call your attention to, though, here in the add and in the subtract, I've got this XCOM push. So in the XCOM push, I'm creating a key in the XCOMs that's going to create an entry for add int1 and add int2 and set the value of those to the integers that we're passing to the add function. And I'm doing the same thing with the sub. And why am I doing that? Because I wanted to demonstrate usage of XCOMs. And so in the multiply and divide parts of this function, first I'm going to print out what it was that we passed to the function initially, and what were the ints that were created here. But then I'm going to go and pull, if it's the multiply, I'm going to pull the add ints and set those to my ints. I'm going to print them on the screen, so print them into the log so I can see that they changed. And then I'm going to do the multiply on the add ints instead of the ints that were set initially. And I'm doing the same thing with sub with the divider. And then lastly, I have a bad operator methodology in here. So if I pass something that isn't in this list, we actually will get that as a result. So how are we passing our operators? Well, if we look at our add task, here's how we're passing the operators. I'm defining an operator and add, and I'm setting a start integer and an end integer. And that's what gets sent into this method for each of the math functions that I'm calling, the do math. And I'm just doing the same thing here with sub, multiply, divide, and bad operator. And then note that here's our little more complex DAG dependencies. And you can see here, I'm demonstrating that you can create a path of dependency for multiple objects at once. So simple path feeds into both hello world and date, and those both then flow out to simple path exit, and the same thing with the others. And if we go and look at our graph, we can see that represented. So here's our start into simple path, then to date and hello world, and then those both pass out to simple path exit. So great, that's all fine and good. Let's go ahead and trigger this DAG and watch it happen. So if we go back to our graph here, so it refreshes, you can see now we're at this state. This is kind of, actually, when you have a much more complex and more, there's a lot more going on in the background, it's really cool to watch this happen. And if you have tasks that skip, that's even cooler. All right, so we know that our add function, here's our add function. We know that it's returning the values that it used. And so if we look at our XCOM, here's our add int 1 and our add int 2, 4 and 8. So we go back then and look at our multiplier and look at our log. We can see here, here's our random int that we set initially in our function, and then we changed it to the 4 and the 8 that were in the add function, and our result then is actually based on 4 times 8. So we've just used some simple Python to reach into the XCOM and pull a value out instead. And you'll notice that now our successes have incremented, right? So we ran 5, 8, 4. Those originally were 1 less than that. I think, let's see here. So that's all fine and good, but what happens? I mean, can we have more complex? Absolutely. The answer to that is absolutely, we can have more complex. So if we take a look here, for example, here's a representation of a DAG that I helped develop. And it does a whole lot of activity. It sets a whole bunch of XCOMs. It drops tables in BigQuery. It copies files. It logs the files that were copied, checks for whether or not there were any logs copied. It does prep of those logs and creates a temporary table, loads it into BigQuery, and then does some cleanup steps. And that code looks like this. It's significantly more complex. And you can even, for example, in this code here is bringing in a whole nother functionality. So this is a common library of functionality that's being used multiple times in the DAGs that are created in that environment. We have multiple instances using the same code, and so there was no point in repeating that code within one object, within each DAG run. So we actually import that as our superlog process. Go back to presentation now. This is a screenshot of what that DAG looks like in a different orientation. And here's just a sample of the code. And then I've included a bunch of resources in this at the end of my slideshow. I can't stress enough Mark Lamberti. This guy is a rock star and amazing. I've learned so much just reading his blogs. If you're going to go and spend time reading a blog, that's definitely where you want to go. Also, this fellow here, he's got some pretty darn good resources. And then, of course, the Astronomer IO blog, and here's a couple of example logs, blog entries that I found were very helpful. There's a couple other articles here. And then this article here is a great article on testing DAGs in the Google Cloud environment, Google Cloud Composer environment. That being said, I guess I'm going to open it up for questions.
Well, first of all, I want to say thank you. It was a really, really good presentation. I want to ask a question. So if I want to run a script, Python script or Bash script, you showed the scripts which are already like part of this execution. But what if you want to run external script? How you call it?
So you could. So there are two ways that you can do that. You can load that Python script. So in the example here, right? So I'm basically loading a Python module here. So that Python module would need to be in the path visible to the DAG, right? To the Airflow executor. It would need to be somewhere in the path. So you would need to put it. Yeah, the recommendation is not to put it in the DAG lib, because if it's in the DAG library, it's going to be attempted to be run every time. So it's recommended to actually create a directory up here that's, something like DAG lib, right?
Mm-hmm.
And so you would put your scripts up in here. And so then you would load those DAG libs from that location. Alternatively, you can, if there is a Python module that you want available to you in your Airflow, you would set that up. You would set that to load during the actual boot up of the environment. You would add that to your configuration. You can tell it to load a pip library.
Okay, so you're not starting the script by using like a subprocess, like creating subshell and start Python in it. So instead you import it and then you invoke some procedure inside this file which you just imported, which is like an entry point to execute all the functionality in this Python script.
So yes and or no. So one would be to refer to it via the path and load it in your script, right? The other is to actually load it as a wheel or into your environment when you boot the environment up. Does that make sense?
Okay. And what about running stuff in parallel? What if I have a script which internally uses multiprocessing to create multiple scripts, right? How I would port it into this into Apache Airflow?
So there are one caution, first of all, is that we don't want to use Airflow's workers to be doing parallel processing, right? We want to use Airflow's workers, the parallelism of Airflow's workers, to trigger a lot of work. Airflow is a orchestration tool. So if I'm understanding your question correctly, you've got a process that is running in a parallel environment, and you want to be able to trigger that and orchestrate that. You would have Airflow start that process in the environment that's got the parallelism already set up, right? So you say you've got a Kubernetes cluster that runs a Spark job. You would have Airflow hit that Kubernetes cluster and say, run that job. You wouldn't say, bring that Spark job and run it within Airflow. You can, not recommend it. So the multiprocessor and parallelism in Airflow is more about how many jobs can I do at one time? How much work can I orchestrate at once?
Okay, let's say I orchestrated and running in parallel jobs, and they actually running in containers on different virtual machines, right?
Yes.
And they have some output, some log files.
Yes.
How I can look at these log files? Are they aggregated back into some one master server? I mean, how this works?
So, I'm using the example of Spark because that's what comes to mind most for me. Is I'm going to actually look at the node that's directing, because I'm drawing a blank on the name of the node now. You've got worker nodes and you've got the I don't think it's called the director node, but you've got a node that manages all that. So the results from the worker nodes come back to that one node, and that's where Airflow is going to be looking for the result, right?
Okay, but Airflow itself has its own master node.
Yes, correct. If it's if it's set up in a multitask environment, yeah, I mean a multi-node environment, yes. And so Zookeeper is doing all of the work of managing that, the parallelism of the tasks themselves. So the task. So when I take a task and I initiate a Spark task on another cluster, I don't have multiple nodes triggering that task. I only have one task triggering that Spark job, right?
Mm-hmm.
And so that job is waiting to hear back from the Spark environment the result. The other tasks are doing other things related to all sorts of other activity, right? So I can trigger 42 different jobs simultaneously and have 42 different nodes waiting for the result from the environment the task that they've initiated. Does that make any sense?
Yes, yes. Chris, you use the term Zookeeper.
Yes.
Is this something like specific in Apache Airflow, or it's just generic term?
No. It's Zookeeper is it's part of the Apache environment for Hadoop. It came from the Hadoop environment, and Zookeeper manages it's part of the management of multiple nodes.
So I guess it's part of your Databricks or like Spark thing. It's not part of Apache Airflow.
No, but if you set up Apache if you set up Airflow in a multi-node environment, Zookeeper will be part of that implementation.
Right. I also want to add that I used your instructions to install Apache Airflow on my Mac, and it was extremely easy, and it worked right away. So I just need to open one window to start the web server, another terminal window to start the scheduler, and then open the browser, and here it is.
And so here's my instance right here. I've got my web server running, I've got my scheduler running, and then this is just the interface, the page that I'm using to manage my Git repo.
So you can run it on Linux, you can run it on Mac. What about Windows? Can people play with it on Windows?
You sure can. Yep, absolutely. They setting up the environment path is a little different, but absolutely. If you've got an environment with Python installed, it's pretty straightforward. Yeah.
So you don't need to use something like Git Bash to emulate Linux, no?
No.
Oh, okay. Cool. I don't have any more questions. Guys, what do you think? Yeah, silence. Everybody's muted.
We're impressed.
It was very good and very informative. Thank you, Chris, by the way. I remember doing that one Google project where I ended up writing a DAG. So a little bit of that was remembered. So that was cool. Of course, that was a project I worked on with you, Chris. Yeah, but it was really good. It was interesting. I don't know if I have any questions. I did put a funny picture in the chat that you should totally look at. And if you've seen the movie that I'm referencing, well, that'll be pretty funny. So there's a movie with Brad Pitt. I think it's
Great
Snatch.
movie, by the way, Rachel. Great movie.
Right? Yeah. And he talks really funny, Brad Pitt, and he sounds like he's saying, "Do you like dogs?" But he says, "Do you like dags?" So every time he said it, I thought of that. So I had to share that.
I also want to add that Chris talked about XCOM. So COM is from communication, and X is like cross communication between the components. So XCOMs. So they usually in JSON format and stored in the database. But you can use them, but you don't have to, because you can just run one component and save your results in, let's say, S3 buckets or somewhere, and then the next component picks this data and continues the processing. So you can do it this way. We're out of time. Chris, thank you so much. And it was a great presentation. Thank you.
Yes, it was really
Yeah,
good. Thank you.
Great. Yeah, thank you so much.
And I
Yeah,
will,
thank you, Chris. Appreciate it.
I will share the Git repo for the sample DAGs that I have in this.